case of PDA. This is parasternal short axis view. This is most anterior part. Upper part of the skin is most anterior part. Lower part of the skin is most posterior part because probe is placed anteriorly in parasternal region. Short axis view. So this is left atrium. This is right atrium, interior septum. This is right ventricle. So this is tricuspid valve. This is main pulmonary artery. This is pulmonary valve. And this is right pulmonary artery branch. And this is patent ductus arteriosus. In the color flow, you can see flow from aorta into pulmonary artery. Chamber that will be enlarged in this case will be left atrium, left ventricle, and pulmonary artery. Because flow is from aorta to pulmonary artery, then pulmonary vein, then left atrium, then left ventricle, and then in aorta. So ultimately, chamber involved is left atrium, left ventricle, and part of main pulmonary artery. So this is the image. You can see this is patent ductus arteriosus. This is the size of PDA. You can measure the size. Now the next image. This is the size of patent ductus arteriosus at pulmonary end, because this is pulmonary end and this is aortic end. So if you measure like this, then the aortic side. This is if you measure like this, and from pulmonary side, then pulmonary end. The size of PDA pulmonary end size is 7.3 millimeter. In this case, this is large PDA. Again the same thing, parasternal short axis view. This is aorta. This is thoracic aorta. This is main pulmonary artery. This is aortic root. You can see aortic valve also. This is parasternal short axis view. Again the same thing. Trivial mitral regurgitation, left atrium, left ventricle dilated in this case. This is mild tricuspid regurgitation jet. This is left atrium, this is right atrium, this is left ventricle, this is right ventricle. This is tricuspid regurgitation jet. Mild TR but severe pulmonary artery hypertension in this case. I will show you in another slide. This is aortic arch. You can see this is left subclavian, this is left common carotid arising directly from arch. And here turbulence, what you see, this turbulence is flow from aorta to pulmonary artery. Now the next. This is left atrium, this is left ventricle, this is right ventricle, this is pulmonary valve, this is main pulmonary artery, and this is PDA, and this is then PDA, and this is descending arch. This is thoracic part of aorta. So you can see this image. This is modified view. This is not parasternal long axis and parasternal short axis view. This view in between short and long axis, that is modified view. And you can see this is right ventricle outlet, main pulmonary artery, PDA, descending arch, and this is thoracic part of aorta. You can see in this image. In next image you can see the same thing with color flow. This is pulmonary regurgitation jet. I want to show you how much pressure is here. And right side TR. Now see, this is the TR jet. This is the peak velocity of TR is 4.18 meter per second. So pressure gradient, peak pressure gradient is 70 millimeter of mercury. So indicating severely raised pulmonary artery pressure, because this person, the child, has become adult, has not gone any corrective operation. That is why this person has developed pulmonary artery, severe pulmonary artery pressure. And that is the point to know. Thank you. If you go severity wise, then size of left atrium is 4.9 0 centimeter and aorta is 1.9 centimeter, indicating left atrium is 2 times that of aorta, indicating severe, that is large PDA. The PDA size is large, because a small PDA will not have left atrium enlargement to that extent. So whenever you find aorta less than half of that of left atrium, that means large PDA. Otherwise, you can also find out by clinical symptoms, severely symptomatic, large PDA, and pulmonary wise systemic circulation ratio, a stroke volume through pulmonary and systemic, that ratio, if you calculate, and pulmonary circulation has 2 times more than that of aorta, then that also indicates large PDA. Thank you.